Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, you've got everything you need to run a fast, reliable, and bulletproof data platform. And for your machine learning workloads, they've got dedicated CPU and GPU instances. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. Free yourself from maintaining brittle data pipelines that require excessive coding and don't operationally scale. With the Ascend Unified Data Engineering Platform, you and your team can easily build autonomous data pipelines that dynamically adapt to changes in data, code, and environment, enabling 10 times faster build velocity and automated maintenance. On Ascend, data engineers can ingest, build, integrate, run, and govern advanced data pipelines with 95% less code. Go to dataengineeringpodcast.com/ascend to start building with a free 30-day trial. You'll partner with a dedicated data engineer at Ascend to help you get started and accelerate your journey from prototype to production. Your host is Tobias Macy, and today I'm interviewing Amar Arikere about the Infoworks platform for enterprise data operations and orchestration. So Amar, can you start by introducing yourself?
Yeah, absolutely. Thank you for having me, Tobias. Yeah, my name is Amar Arikere. I'm the founder and Chief Technology Officer at Infoworks. So my background is building large-scale data systems. I started my career as a software engineer. I built large-scale data systems at Google. I built the first data warehouse on Bigtable at Google, and then analytics platform that ran all of the internal analytics there. And that's really how I got started in data management. There's a lot of inspiration from that work that I did there in starting Infoworks.
So what was your best resource for being able to learn about some of the best practices and the discovery involved in being able to build out that data warehouse on top of Bigtable and some of the challenges that you faced in the process?
So building a big data warehouse, a petabyte scale system on top of Bigtable and big data technologies was pretty brand new. So we were doing the world's first data warehouse on top of Bigtable, and the resources were really the original inventors of Bigtable and the big data technologies inside Google. And in fact, a lot of the open source systems, Hadoop and Spark, came out of the original paper that was published out of Google. So and I had access to those resources inside Google, so to speak. And that's how I was able to build it and ran a pretty successful analytics platform that had thousands of use cases, thousands of users, and petabyte scale data sets.
And now you've built out the Infoworks platform to be able to solve some of the challenges that you've experienced in the big data space and some of the problems that are inherent to larger organizations. I'm wondering if you can give a bit more detail into what you've built at Infoworks and some of the story behind how it got started.
Yeah, as I said earlier, my first exposure to the large-scale data system was at Google. I built the world's first data warehouse on Bigtable there. And after Google, I joined a company called Zynga. It's a social gaming company. And they had a unique challenge of large-scale data sets, but also needed to make predictions and analytics on top of it very quickly. And over there, I built an in-memory database supporting about 100 million players. Became the world's largest in-memory database at that time. And the unique thing that I did there was to build like thousands of analytics pipelines, that used to feed everything about gaming dashboards to, the gamers' behavior and recommendations and so on. So the lesson that I learned building these two systems was that there was a need to automate a lot of the data operations in lots of enterprises. And the born digital companies like the Google and Zynga and Facebook and Amazon, they had built all these platforms for their internal consumption. It made sense that this is something that's going to be required by any data-driven organization. That was the sort of the inspiration to start Infoworks. And the engineering and the product team that has built Infoworks essentially have the same background that I have, which is running large-scale analytics pipelines. And when we talk about large scale, I'm talking about thousands of analytics pipelines being built and managed on this platform.
And what are some of the fundamental challenges that often plague organizations that are dealing with quote unquote big data? And how do those challenges change or compound in the context of an enterprise organization and the organizational complexities that manifest there?
This is a great question. If you look at the usage of data and how people are managing their data assets, you can really segment the world into two sets of companies. There are the born digital companies like the Google, Facebook, Amazon, Netflix, and Zynga, and so on, where they have a foundational platform on which they are essentially always building out a 360-degree view of their business. On the other side, you have all these other companies who are in various stages of data maturity, where the approach is to do use case by use case, sort of a build out. So they are gathering data for every use case. And as a result, there is a fragmentation of their data assets within the company. And to gather a 360-degree view of the business, it becomes pretty challenging. And in this world, it's not built on a foundational platform so much. It's built on point tools. And there is a lot of glue code that dominates the world. And that becomes also very challenging. The data gets fragmented, teams get fragmented, the skill sets get fragmented. So these are some fundamental challenges that many companies are facing when they have to deal with data that represents their business. You can call it big data because the amount of data is also large, the complexity is pretty large, and how do you sort of manage all of this becomes very critical.
And in terms of the enterprise organizations, what are some of the unique needs that they have of their data that aren't necessarily going to manifest at either smaller scales or for newer companies that are maybe large but don't necessarily have as much of that legacy infrastructure and legacy data that they need to be able to support?
Yeah. So in enterprises, number one, now every enterprise is a data-driven organization. So the need for data itself is accelerating. Every department is becoming data-driven, which means they need data to make decisions. And as a result, every organization, in order to become data-driven, they really have to build thousands of use cases and where they're essentially using their data, their fresh data. That becomes also very important to make their decision. And today's state of the art is to have 10 or 20 use cases that will be built at best, because in today's architecture, you have to hire a team of engineers who are coding those pipelines, and then it takes an amount of time to sort of operationalize it in production, and there is a limit to what you can do versus automating a lot of the data operations that is going to get you the agility that you need to run an organization and become much more of the data-driven organization. So that's a unique set of challenges that enterprises face. They also have the legacy tooling and the point tools and the glue code that that you mentioned earlier, which becomes a challenge to maintain when you're introducing sort of new use cases.
And the big data technologies that we have now are generally fairly built for purpose, either by the original organization that used it and then open sourced it, or by the academic institution that was using it for a particular area of research, which can lead to some sharp edges or difficulties in integrating it into the larger ecosystem. But from your perspective, what have you found to be some of the design or technical limitations of those existing technologies, and how does that contribute to the overall difficulty of using or integrating them effectively into an enterprise organization?
Yeah, I think the legacy integration technologies, right? They have a limitation. Number one, it is still pretty coding heavy, and you still have a lot of coding that you have to do. There are many tools which are visual programming based, but it's still programming. So which means you are still programming and building out those pipelines and things like that. What happens when there are schema changes? What happens when you have to do time series analysis? None of those things are automated. You're sort of building out all of this manually. So the automation part is very critical to achieve these thousands of use cases to become data-driven organization. So that's one limitation in sort of the existing legacy technologies that are there. And also many of the legacy technologies or the integration tools were built for a SQL-based database. And as a result, it becomes SQL-centric. In a distributed world, whether you're using big data technologies like Hadoop or Spark, it's important for the tooling layer, the data engineering layer, to know about the distributed infrastructure. One example is the distributed technologies have this, parallelism built in. But your data needs to be organized. And what I mean by data needs to be organized to make use of that parallelism is that the data needs to be partitioned rightly. And SQL-based technologies do not necessarily deal with that. So that's one of the technical challenges we solve with Infoworks, where if you have a partition of 1, you get a parallelism of 1. If you have a partition of 100, you get a parallelism of 100. But that organizing the data into right partitions is something that we do. We support what is called hierarchical partitioning to support those kinds of getting the benefit of the underlying technologies, and that becomes important as you are dealing with larger volumes of data, more use cases, and so on. You need to get the power of your distributed big data architecture into your tooling layer.
So for an organization that might be looking to use Infoworks to solve some of their data challenges, what are some of the signs or symptoms that would lead them in your direction?
So one of the challenges that we see is, and so the other thing that a number of the companies have already built is, sort of the do-it-yourself platform for this, especially the new technologies like the Hadoop and Spark-based systems. One of the challenges that they face is, the continuing investment of engineering in maintaining those, do-it-yourself platforms. And some of the do-it-yourself platforms are essentially built on point tools with a lot of glue code. So when maintenance becomes a challenge, many of the enterprises, we have worked with them, they have come to us, where we have successfully replaced their in-house do-it-yourself platform with an Infoworks platform that has given them the agility to run their organization. So that's one of the sort of a successful journey for an enterprise.
And so for the organizations that are integrating Infoworks into their system, what are some of the tools or technologies that they might be replacing? And what is the process of actually integrating the Infoworks platform into their data technologies that are already running?
So one thing that, from a replacement standpoint, there are a number of legacy integration tools. It could be the ETL tools that you may be familiar with, like Informatica, Talent, Pentaho. These are the legacy integration tools. We have replaced in many instances. It could be ingestion tools. It could be like Scoop or NiFi or Golden Gate in some cases for doing CDC. It could be like cloud native tools that are there for whether it is for ETL or ingestion or orchestration tools. So these are some of the tools where we have replaced. And with Infoworks, just to first sort of talk about what is it that we do, Infoworks is an enterprise data operations and orchestration platform. So it spans all of the data operations functionality, like ingestion, CDC, merge, and building a time series of your data sets as data comes in, data transformation, data modeling, and then orchestrating all these pipelines in production. So we span all the gamuts of the data operations. So these are the technologies and the tools that we replace in an enterprise setting.
And then as far as the integrations that you build to make sure that you can work with all the systems that are pre-existing at these organizations, how do you identify and prioritize your work to make sure that you have sufficient support for being able to provide the functionality that is needed?
Yeah, so there are 3 layers of integration that you can sort of you can categorize in this world of data operations. On the one side, you have the data sources. So we support integrations into most of the enterprise data sources. We have 30 plus data sources, all the way from Oracle, Teradata, SQL Server, file systems, streaming data sources, mainframe connectors, API-based data sources, and so on. And typically, it's mostly it's sufficient in many cases, to sort of ingest data, onboard data sources, and so on. We also have a connector framework. In case one of the data sources you have is not supported, you can easily add a support for your new data source and customize it and build it out. And so those connectors can be added as an enhancement into the base platform you are building on top of the existing platform. And in the other category of integration is, if you have your own custom code for data transformations and things like that, we support 2 kinds of integration. You can sort of bring your own code and make it as a node inside Infoworks. Or we also support a loosely coupled integration where you can sort of call into your system, pass parameters and all that on all those things using our orchestrator mechanism, which manages dependencies and parameter passing and fault tolerant sort of execution of those pipelines, and then pass the control back into Infoworks to for further processing. So that's much more of a loosely coupled integration. And the third one is in connecting to different layers for data consumption, whether it's cloud endpoints, it could be like BigQuery or some other technologies that you want to deliver the data. So we support a number of those integrations as well. And the way we prioritize these integration is really we are very tightly connected to our customers and the use cases that they are building. We are essentially supporting those initiatives and prioritizing based upon where their use cases are going.
And what are some of the key principles on which the Infoworks platform is built that have guided your development and improvements of the overall capabilities of the system?
Yeah, absolutely. So Infoworks, we call it the three pillars. Infoworks platform is built on these three pillars. The first one is deep automation. So and that's our background. Anything and everything that we can automate in data operations, we have built-in automation, so which enables people to build out these thousands of use cases. The second one is infrastructure abstraction. Because there is going to be different kinds of data computation technologies, distributed execution engines, and so on, we have built this on an infrastructure abstraction so we can deploy it in any sort of an environment, whether it's on-premise, in the cloud, or in a hybrid setting. And the third principle on which we have built this platform is to make all of the data operations available in a single place. So you can think of it as an integrated solution, whether it's for onboarding a data source, transforming your data source, or operationalizing it. So all these three functionality is available in a single place. So it's easy for you to adapt to changes as things are evolving in your use case. And the fourth one, which is important, I'm just going to add that is that it's built natively for this big data based systems, the distributed architectures, and that is very important in the sense that these parallel engines provide a lot of power, and unless you take provide a native integration into these parallel engines, you're not going to get the benefit of it. And that's that's what we have done with this Infoworks platform.
Can you talk a bit more about how the Infoworks platform itself is architected and some of the ways that that design has evolved since you first began working on it?
Yeah, absolutely. So, our origins were in terms of automating the data operations, and that's where we came from. And the way that the Infoworks system was orchestrated was essentially that it provided automation for all of the data operations, and it encompasses the entire gamut of the data operations. So we start with crawling of a data source. So we fetch everything about a data source, like the metadata, the relationships between tables and things like that. And once the crawling of the metadata is completed, you have the option of ingesting the data, both from a historical load standpoint, where you need to load all of the data in the beginning, to doing CDC, right? The change data capture, where as data is changing in the source systems, you can bring changing data into your analytics platform or your big data system. And we support something called as change schema capture. So if there is a change in schema, it automatically adapts to those changes. It does things like backfills and all the things that you need to do for supporting the new schema. And one of the unique things about a big data system is the big data systems are typically immutable, which means if there are records updated in the source system, there is no easy way for you to change that on your big data system where you're building your analytics. So we support a continuous merge process. So the continuous merge process is automatically syncs the data and gives you a view into the data that provides an updated view, right? And that's very important in this new architecture, where you're dealing with immutable systems. And as the data is coming in, we are auditing with the time series. So the data is organized on a time series with current and history tables. So this is something that lets you do a lot of the time series analysis very quickly, and that essentially builds your data catalog that is continuously refreshed and maintained. And it provides the basis for the rest of the processing. And we have this concept of data domains where the data catalog can be then provisioned into these data domains where data admins and data scientists can come in and perform transformation operations, data modeling operations on top of that data catalog. And they're only seeing a slice of the data catalog. So, that way they can, you can have control over the data access and who sees what. And the data transformation pipeline is also heavily automated. When you compare Infoworks against the visual programming approaches, if you have to deal with things like incremental pipeline, it's a single click operation in Infoworks versus in a legacy ETL tool, you have to deal with things like auditing the tables on a time axis, capturing like watermarks so that you can sort of do incremental processing later and so on. All these things have to be manually done. So those are the kinds of automation that are built in. Slowly changing dimensions or a click of a button, click a button and then it organizes the data in the data model in current and history tables and so on. Audit capture, lineage, versioning is all performed on those data transformation pipeline. And once the data transformation logic is built out, the final set is your data model. And the data model, you can also accelerate into an in-memory data model. So that way, you not only sort of get your raw data, but you're shaping the data into the right format in a data model, but also creating the data model at the right speed. You can get, a data model in an in-memory system is going to be 8 to 10 times faster than on your, base system. So those kinds of accelerated data models, you can do it, right in the platform itself. And it also provides access to integrate into your ML and AI algorithms as well, and supports things like training of your data models. And once these things are, built out, the data models are built out nicely and it represents your business, you can export those data models into other consumption endpoints. It could be, a BigQuery in the cloud or Snowflake or some other technologies that you're using to consume those data models, while you are continuously refreshing it and maintaining it and delivering that data models for consumption. Or it could be into visual tools like Tableau and Click and so on. And the last stage of this is to orchestrate these pipelines so that you're running them every 15 minutes or every hour or every day, and manage dependencies, parameter parsing, making it fault tolerance with retry and restartability, and managing it on a day-to-day basis. So we have an orchestrator that can be used to orchestrate these pipelines and deliver the end result. And all of this is built in a single platform. So that way you can have data engineers, data scientists, data analysts, and production support or production admins all work on a single collaborative system.
There are a few things that I want to pull out from there. One of those is the concept of the change schema capture that you mentioned and being able to propagate those schema changes throughout the different systems, which I know is one of the canonical problems that data engineers are faced with, is how the evolution of data in the source systems can be reflected downstream. And I'm wondering what you have found to be some of the useful strategies on that point and some of the challenges that you've faced in terms of being able to reflect those schema changes in a way that is non-destructive at the destination systems.
Yeah, absolutely. This is a great question. So one of the things that we did, I think as a strategy that we have followed in our system, is we provide a automated change schema capture, but at the same time, we provide it also in a way that you can be notified and there can be a human involvement and an authorization before those changes are automatically applied. So that is a strategy we have applied across the entire system, especially for the schema change capture. So that way, you can automate certain kinds of changes into the system, and then for other kinds of schema changes, you can also make it manual in the sense that you have to get notified, you need to be authorized or approved before those changes are percolated into the system. So that strategy has helped because there is no one size automation fits all kind of a story, especially when it comes to schema changes. And there are, in many cases, a change in schema that should not have been really performed in the source systems, and that shows up in your data warehouse systems. In many cases requires that human intervention. So that's one of the things that we have learned that has worked out pretty good.
And then another element is the data cataloging. And I know that discoverability and reuse of data assets in general is one of the biggest challenges that face organizations of all sizes. And I'm sure that that is compounded with the different business units that exist within an enterprise organization. And I'm wondering how you address that discoverability in your platform to make sure that you can cut down on rework and duplicated effort between different silos.
Yeah, the data catalog is something that is central to the organization. I mean, it truly represents the data assets that an enterprise needs to manage, and it has to have a lot more metadata information for managers of the data. So one of the things that we have done is, I mean, the data catalog is searchable and taggable, so that's like pretty much many systems have it. We also have a mechanism to enhance the data catalog with both technical glossary as well as business glossary, so you can upload Excel files that represents your the business metadata, and then the system tags the business metadata into those columns and tables and so on, and again everything becomes searchable as you're uploading and enhancing the system. And that's one part of it. The other thing that we have also done is called as data engagement dashboard. So as you're using this data day in and day out, whether by running the pipelines and building data models and orchestrating and running it in production and so on, we are also capturing and showing what are the most critical, important data assets within your organization. So we are calling it the data engagement dashboard. So you can see what are the top 5 data models, what are the top 5 raw data sources, and who are the most heavy users of your data, and so on. So you get a view for what are the critical data assets in an organization, and data assets are just like any other sort of physical assets that a company may have, whether like it could be stores or machinery or equipment and so on. There has to be a management layer, and that's how we are viewing it, and we are putting a lot of sort of emphasis on that data engagement dashboard for the managers of data.
For the different roles that are interacting with Infoworks, I'm wondering if you can give a high-level view of the different responsibilities within an organization that might be using Infoworks in their day-to-day and the different workflows that they might engage in with your platform.
Yeah. So we have the platform supports this role-based access control. So typically what we have seen is data engineers are mostly interested in building that onboarding of their data source and building out the data catalog. So typically that's where they are focused on. So data engineers build out the data catalog. They then provision in what we call as data domains, which is basically a subset of data catalog is then provisioned for a certain set of users for them to like build transformation pipelines and so on. The second set of users are data analysts and data scientists. So the data scientists and data analysts, they are working with a partial set of data catalog and then building out transformation pipelines. They're shaping the data and creating the data models within what we're calling it as data domains. And the final data models are, when they're ready for consumption, they're typically working with production admins. The production admins then take the pipelines and the artifacts they have created and they migrate it from dev to production, right? The production systems are typically managed by production admins, and they are then orchestrating it and deploying it in production, and they're also monitoring that in production. So Infoworks provides a orchestrator where they can monitor and see how things are going. They can also look at the SLAs once it is deployed in production and make certain changes if needed, whether by passing parameters or by increasing capacity. Like if a process is going very slow and it's taking a long time, they can add more compute into that process and get the SLAs to run within the thresholds that they have. So these are the 3 different kinds of roles. It's the data engineers who are interested in building the data catalog, the data analysts and data scientists who are interested in building out the data models that is shaped for business consumption, and the production admins who are orchestrating the workflows in production.
And throughout those different stages, can you talk through the overall life cycle of a unit of data, whether that's a single record or a large batch of data, and how that flows through the Infoworks platform and the different subsystems that it touches on at each stage of its life cycle?
So the life cycle of the data or a unit of data in Infoworks is, first part of this is that when a data engineer sets up a connection to a data source, Infoworks is crawling and understanding the metadata of that data, which is all the structure and the information and the data pattern is pulled in. And then the second part of it is to actually ingest the raw records itself. So the raw data is ingested. That is the first load is the historical load, where you're bringing in all of the data sets for a certain table or a certain schema and so on. And then the second phase of this ingestion is the CDC, where you're bringing in the changing data sets. Now, if this data represented a new record, it'll be handled in one way. If it was an updated record, then it goes and it gets processed in our merge process. So we have a continuous merge process, which gets, essentially takes the updated record and merges into the base set of tables that's on the big data environment. And this data gets tagged. So there is a time axis on which this data gets tagged. And it may be also pushed into current tables or history tables based upon if this was an old record versus if this is the current record that is represented on the source side. So that's all the things that happens to a unit of data when you're building out a data catalog. So that's the first phase of this whole thing. The second part of this is the data transformation. So once the data is brought in and nicely organized on a time axis and cataloged, there is a transformation pipeline which is essentially applied on top of your data, and that transformation pipeline has certain kinds of operations like join nodes and unions and other kinds of transformations that you may be applying before that data shows up in a data model. There is a lot of the management that happens in a transformation pipeline, like if you need to know who made what changes to the transformation logic, lineage, versioning, and all those things. So that's orthogonal to the flow of the data itself. We are keeping track of everything that happened to the transformation logic. And once the data shows up into the data model, the final step is that it could then be exported into a consumption layer where it could be some cloud endpoints or some other sort of a SQL engine or things like that. And then, as we discussed earlier, the final part of this whole thing is orchestrating it in production. So this is one part of the data flow. But once you have this operationalized in production, you're running these things every hour, every 10 minutes, or whatever frequency that you need to manage.
The interface that is available for the data engineers and the analysts to be able to build out these different data flows and interact with their data is largely UI oriented with a low-code approach and being able to click and drag different components. I'm wondering what you have found to be some of the design challenges that you face in being able to provide an appropriate level of control and expressivity while still being able to make it accessible to people who don't either have the technical capacity or the time to be able to dig deep into the code level aspects of the systems.
So the interesting thing is, our UI subsystem is built upon our API layer. So you're right, all of the things, the three different personas or roles who are using Infoworks, they are using this collaborative UI platform and managing their work, whether it is to build out data catalog or transformation or operationalizing the data. And in some cases, there are some of our customers are also using this platform without a UI, using an API to drive the pipelines in production. So that's another sort of a usage category as well. So one of the things that we have done is there is a challenge in terms of making it completely UI, because in some cases, you need to have programmatic access to various points within the platform. And we have an ability where, since our entire platform has got APIs, you can sort of tap into different parts of our system and do an integration. One example is if you have a custom transformation code and you want to be able to sort of use that, you can drag and drop and put in a custom code inside of Infoworks and make it into a node that becomes a reusable node, and you can pass parameters to it and so on. So this is one approach of reusing some of the things that you may already have. We also support integration using our orchestrator, which you can call it the loosely coupled integration, where you can as part of your transformation, you can pass control to your system that is a pre-existing system, pass parameters and so on, and then have once it is completed, have it come back into Infoworks and continue on. So this way, you have a mechanism for you to integrate into sort of existing systems.
And then in terms of the workflow of the people who are defining those pipelines, what do you have available for being able to handle versioning of them and releasing them to different environments to validate them and test them, or for being able to look back at past versions and do historical analysis?
There is a built-in version control for the pipelines. So you can have data analysts work on a new version while there is an existing version that's being run in production. And once it's the development is complete, you can move the new version or migrate the new version into production. So you have the ability to sort of tag it, version it, and all those things. We also support integrating into your sort of existing config management tools such as GitHub. So those are things that are available. And one of the unique things is since this is a platform that's API driven, you can also build CI/CD on top of it and perform things like data validation and data reconciliation. We support things like record count based data reconciliation out of the box. So if you need to run a reconciliation job at the end of every week, and it you need to just click a button and those reconciliation processes will run. You can also perform sort of custom data validation. You can specify slices of data. So things like if you want to take a slice of your data and you can say, show me the number of sales that happened in this zip code, and that should be a slice of your data that you always want to validate at the end of a certain day, you can specify those slices of data, right? And then it generates the reports and statistics to make sure that everything is running fine. And that way you can sort of version the pipelines and validate it and manage this on an ongoing basis.
And then the graphical paradigm can sometimes break down because of the fact that there are elements that are difficult to translate into a UI paradigm, or that require some specific custom development to be able to handle. And I'm wondering what you have seen as being some of those edge cases where there's the necessity to be able to drop down to the code level, and what you have as far as an escape hatch in your platform.
In cases when the customers, they have to perform a custom transformation, and they're either have an existing code base they want to use, or they want to write code in some of the cases. What we support is an ability to do custom transformation node. So we have a mechanism in which we can support adding custom transformation code, whether it's in Java, Scala, or Python, and you can code that in and then drop it into in a certain format into Infoworks, and it becomes a reusable drag and droppable node. And you can attach that within the Infoworks platform. You can drag and drop it, build it out, and reuse it in various ways that you may want to use. And that way you are leveraging your existing assets. So it's not something that you have to recode everything in this new environment. And the other thing that we also do is that we support integrating Java-based transformation nodes with Scala or Python-based transformation node without having to go back into the disk. In other words, we are doing in-memory transformations. You can say passing data frames between these nodes, so there is no penalty for you to write it in different languages.
And then what are the cases where Infoworks is the wrong choice for a platform for handling data orchestration and integration?
Yeah, no, this is a great question. So one of the things is, if this is Infoworks is a platform for building out data operations and data orchestration for batch style use cases and micro batch style use cases. So if you're looking to do real time analytics with millisecond sort of response time, then this is not the right choice of the platform. If you are looking to perform a use case which requires data models to be updated and made available in few minutes, I would say 2 minutes and above, then this would be a right choice of technologies.
And in your experience of building and growing Infoworks as a business and as a technical platform, what are some of the most challenging or interesting or unexpected lessons that you've learned in the process?
Yeah, one of the things is, as we have discussed, I mean, Infoworks is a highly automated system. And one of the things that we have learned is automation by itself is also not sufficient. And as a result, we have invested in customer success within our enterprise customers. And we have customers who have built thousands of pipelines and run in production, 400 plus use cases in 12 months. So they've able to gain the agility that they did not have before Infoworks. And that we were able to achieve. I mean, automation was definitely the root cause and the reason why that agility came into play. But we have also invested in training the customer and advising them in this new paradigm of doing data operations and orchestration. And I think that was, I would say, a lesson learned in terms of how automation plays out. You still need that education, that advisory sort of a role, and we have heavily invested in that. We're also investing in a lot of the self-service capabilities where there is like sort of tutorials, the video tutorials and other things that we are investing, and also recommendation. So when data analysts and data scientists are performing certain operations, we are essentially analyzing what they are doing and recommending in the app itself or in the platform itself to guide them. So these are things which we have learned as a result of working with large number of customers. And all those heuristics, the rules of how people are using our system is we are applying machine intelligence to sort of recommend what they should be doing. So, and I think those things are having a bigger impact, or I'd say having a big impact in usage as well.
What are some of the most notable ways that the overall big data landscape has evolved since you first began working on Infoworks, and what are some of the industry trends that you're most excited for?
Yeah, since we started started Infoworks, I think one thing we have seen is that there is a secular movement towards more efficient technologies when it comes to distributed execution engines for data processing. So what I mean by that is we had this open source Hadoop, which started with Apache Hadoop, and then after that the Spark technologies which came in, which essentially made MapReduce sort of work within memory, and then now we are seeing ephemeral clusters, which means you don't need to have a one big large static cluster. You can have a cluster startup and taken down for each sort of workflow. So all these things are essentially solving two things. One is the complexity of managing a cluster, and second thing is the cost or the efficiency of data processing. Being in this world of data for a while now, I think one thing which has become clear is that there is more data today than all of the data computation ability as human beings, right? So as a result, there is a need for much more efficient data processing technologies, and that's a movement that's going to be happening. And what we have done at Infoworks is to really build this data operations and orchestration platform with an infrastructure abstraction, so we can run on any kind of execution engines and storage technologies. And that's one of the things that we see that's very exciting. We're going to see many more technologies for data processing.
And are there any new features that you have planned for the near to medium term, or overall improvements or enhancements to the platform that you'd like to share before we close out the show?
Yeah, I think one of the things that we are working on in our roadmap is the self-service initiative, where there is going to be sort of a guided tutorial as you're using the product. Recommendations for various things you can do. And we have learned a lot from many large customers using, and I think one thing we have seen is that our customers are running thousands of pipelines in production, and we have a lot of heuristics and a lot of things that we have learned from this, and we are using machine intelligence to sort of surface it as people are building out pipelines and using the product.
Well, for anybody who wants to follow along with the work that you're doing, or get in touch or get some more information about the platform that you've built out, I'll have you add your preferred contact information to the show notes. And so with that, I'd like to ask you a final question of what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, one of the biggest gap that I see in the tooling for data management today is that data operations are fragmented because there is a lot of point tools and you have to write a lot of glue code to stitch them together. And doing automation of data operations in such a setting, it becomes very challenging. That's one of the biggest gaps that I see. And, there was one research paper from Google which said that in a typical sort of ML use case, about 5% tends to be ML code and 95% is glue code. Right. And I think having a platform that integrates all of these technologies or all of the functionality that is required from onboarding a data source, transforming it, and operationalizing it, it becomes very important.
All right. Well, thank you very much for taking the time today to join me and share your experience of building out the Infoworks platform. It's definitely a very interesting system and one that solves a very complicated challenge for larger organizations and, well, for any organization. So definitely appreciate the work that you're doing there. And I thank you again for taking the time, and I hope you have a good rest of your day.
Thank you for having me, Tobias.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.